like you to explain coterminal angles.
Okay.
And then I do practice problems on angular speed.
Okay. Coterminal, excuse me, 1 second, I gotta sneeze. Okay. Coterminal angles are multiples of 360. So if I told you I got an angle that's 30 degrees, well, 390 is coterminal, 750 is coterminal. Sorry, what?
I didn't.
Okay. So that's all coterminal means. And it goes in both directions. In other words, also minus 300 is coterminal. Minus 660 is coterminal. Are you there, Max?
Yeah, it was weird. All you said was on the screen, it just popped up.
Almost look like it says my network connection has been reestablished. So you lost it for a minute?
Yeah, I didn't see it.
Okay.
But now I think I can.
Okay. Do you get what coterminal is?
Yeah, I think so.
Okay. Do you have some problems regarding coterminal?
Well, actually, just had some problems on English speed from yesterday.
Okay, let's do one of those.
So, a car is moving at 65 miles an hour. The diameter of its wheel is 2.5 feet. And then find the number of revolutions per minute the wheels are rotating at.
All right. Most important thing about this is remembering the general formula. If you can remember the general formula, then you can answer it regardless of whether they give you RPM and ask you about speed, or if they give you speed and RPM and ask you about diameter, you're going to be able to figure it out. Okay? It's the RPM. I tell you what the easiest way to do this is to put the units down. So it's, and I'm going to do it down below because it's so darn long.
Yeah.
I need the room. So we got revolutions per minute. And on the other end, we got miles per hour. Okay? So we got to get from revolutions per minute to miles per hour. And
What is the opposite?
no, they're not really the opposite. They're on opposite sides of the equation.
Yeah, I know, but for this,
I'm going to let revolutions per minute be x. Because we don't know what it is. That's what they're asking us to solve for. Okay? Hold on 1 second. Got to blow my nose now. All right. In fact, let's not use x, because that can be confused for multiplication. Let's use r. R revolutions per minute. Now, since we want to end up with hours in the denominator, what's the next term I'm going to multiply that by?
you do 60 minutes and over 1 hour.
Okay, good. Minutes are going to cancel. Now I got to somehow convert the revolutions to miles.
Well, would you multiply it by 2 pi radians?
Yeah, the conversion factor is 2 pi radians per 1 revolution.
For 1 second.
So the revs cancel. Now I got radians per hour. So I somehow have to figure out what the distance of a radian is.
Well, it's 1.25 feet, so...
Okay, so it's 1.25 feet per 1 radian. In other words, that is like the definition of radian. It is the distance of the arc length, and the arc length is what we care about here. In other words, we're dealing with a circular wheel, so we want to know what the arc length is. That's how far the car is going to go, is however that turns, the circumference is the distance you go. Okay? Now we got radians gone away and we're in feet per hour. So there's not much more to do. What's the next conversion factor?
1 mile over 5280 feet.
Now I think we've got miles per hour, correct? Yeah. There's miles per hour, which means is all you've got to do. So here's what we've got. I'm going to forget the units for a moment. I know I got it right because the units cancel properly. And now I'm going to solve for R. R times 60 times 2 pi times 1.25 all divided by 5280 equals what?
You want me to put it in, or is it equal?
No, what are the miles per hour? They gave us that. So it's 65, right. We know the units all work. I've already tested out the units. Okay? So now we got one equation and one variable, R, and we know it's going to be revolutions per minute, whatever that number comes out to be.
Yeah.
You have any trouble solving that for R?
I didn't think so.
Okay, no, you're gonna multiply both sides by 5280, and then you're gonna divide both sides by that. So R is gonna be 65 times 5280 divided by 60 times 2 pi times 1.25, whatever that number is. That's the number of revolutions per minute that this wheel is turning in order for that car to be able to go 65 miles an hour. Okay? So the key really is it's 1, 2, 3, 4, 5 things multiplied together that produce miles per hour. That's what you have to remember is this general equation that I've written here. Sometimes they give you R and you got to figure out the miles per hour. Sometimes they give you the miles per hour and they give you R and you got to figure out the radius, that number. There's only 3 things you're going to have to figure out, and that is the revolutions per minute, the radius of the wheel, or the speed of the car. All of these other conversion factors are constants. They never change. In other words, it's always 60 minutes per hour, it's always 1 mile per 5280, and it's always 2 pi radians per 1 revolution. So 3 of those constants, that one never changes, that one never changes, that one does not change. The 3 that could be different are that one, and that one.
Okay.
So they might ask you about any of the 3, But the most important thing to remember is the original, the full equation, the general equation, like I've written it right here. Just remember that, and then it's a question of what they're asking for. All right, what else?
So this one is assuming that the latitude. Assuming that Earth is a sphere of radius 6,378 kilometers.
6,378 km, okay, that's its radius, okay.
What is the difference in latitude of Lynchburg, Virginia, and Myrtle Beach, South Carolina, where Lynchburg is 400 kilometers due north of Myrtle Beach?
I'm not going to be very good on this problem. Although it shouldn't be that hard. I always had trouble on this problem. And almost nobody ever gives it to me. Seriously. You're one of the very few people that have given me this problem. Let's see if we could figure it out. I'm not sure I know how to do it. But there's the Earth. There's the radius, 6,378. And it's talking latitude or longitude?
Latitude.
Okay, which are the vertical separations, correct?
Yeah.
Okay. And what's the rest of the information?
The one is 400 kilometers due north.
Cannot understand what you're saying, Max. Say again.
So Lynchburg is 400 kilometers due north of Myrtle Beach.
Okay, hold on. Don't say anything. Okay, so there's Lynchburg. And since it's due north, it's on the same latitude line.
Well, it's asking what is the difference in latitude?
Well, latitude is the vertical or the horizontal? Must be the vertical.
Yeah.
So the difference in latitude is 0 if it's due north. In other words, everything on the same latitude is due north or due south of one another. Whether it's 400 miles or not doesn't matter. Any city that's on that latitude line, there's no difference in latitude. If I looked at 6 cities, now I might have my latitudes and longitudes backwards. Like I said, I don't get a lot of problems. Hold on a second. Let me pull it up on Google here.
Yeah, I have the answer in the back of the book. You want to see what it says?
Not cared with the answer so much as the meaning of latitude. Latitude. I suppose I should know this, but I get so few questions about it that I never remember. Here, let's Google latitude from Wikipedia. Sure would have been easier if they'd have drawn a map. Do you know what latitude is as opposed to longitude?
I am confused also. I don't think Google latitude is the same as latitude, though.
No, it's not the same. I know that. One of them is vertical and one's horizontal. In other words, the lines that go this way, I believe, are longitude.
Yeah.
Okay, so that's longitude. This is latitude, or else I got it backwards. I don't know. If you know, please help me.
Here, I just, alright, I just did it. So, images.
Here, let me look in my book. I've got a problem on latitude, longitude in this book. Let me see if I can.
Latitude is the horizontal line.
Ah, okay. That makes more sense. Now it makes sense as to why they're asking the question.
Yeah.
All right. So the latitude is the horizontal line.
Yeah.
Well, I'm not sure that helps, but what that means is they want the difference in latitude for 400 miles. Well, we can figure that out, kinda, I think.
Is it asking for like the arc?
I don't know. Let's look at the Earth from the side. Okay, we're looking at it from the side. And here's the latitude lines.
Okay.
And there's Lynchburg. There's Myrtle Beach. And the radius of this sphere is 6378. So we also know that that angle is going to be the difference in latitude, correct?
Which angle?
Well, let's call this O, L-O-M.
Yeah.
Okay. Well, we know that 400 miles represents how much of that circumference? First of all, what is the half circumference that we're looking at here?
The half circumference?
Yeah, the circumference of the entire globe is 2 pi r. So it's 12,756 is the circumference of the planet. Divided by 2 is 6,378. So from here all the way to there is 6,378 times pi. Multiply 6,378 times pi. Tell me what you get.
Okay. 20,000, 30,000,
I don't care about anything after that. That's fine. 20,037. So that's how far it is from the North Pole to the South Pole, right?
On the circumference.
Half of the circumference.
Yeah.
The circumference would be 2 pi r. So the circumference would be twice this number, 20,037. Now the question is, this is 400 miles, okay?
Yeah.
So the ratio that concerns me is 400 divided by 20,037. The question that I don't know is, how many degrees is it from the North Pole to the South Pole? Is it 180 or is it 360? I do not know. Do you?
How many degrees is it from west?
Well, in order to answer this problem, we know that we're looking at an angle that is pretty small, right?
Yeah, it's like 4 degrees-ish, I think.
Well, that's my question. Is it 180 degrees from South Pole to North Pole? Or is it 360? I don't know.
I think it's 180.
Okay, so let's assume it's 180. Then our answer is going to be 400 divided by that arc length times 180. What's that answer?
It's 3.59.
Degrees?
Well, I thought it is 3.59. Yeah, it's 3.59 degrees.
Okay, good. That should, if I'm doing everything correct, that should be your latitude difference between Myrtle Beach and whatever city was the other one. Do you have an answer on this one?
It gives me the odds, and I was actually write down. But the other problem, that one that was next to it was the same problem, except for it was 460 instead of 400 miles, and the answer was 4 degrees.
So right. Looks like we're in the right ballpark, huh? So yeah. The next one would be 450 over 2037 times 180. See if you get that correct answer. Or in other words, if you know the answer to this one, then we can see whether we're doing it properly. Yeah. Sounds like we probably are, but...
Yeah, 0.04,
what?
We did it correctly.
Okay, good. All right. Well, there's a case of where I didn't know how to do it, but I did. I just wasn't sure. Okay, what I didn't know was, is half of the Earth 180 degrees? And I wasn't positive it would be. Because you're talking about dividing latitude up.
Yeah, I Googled it and I just got a picture that was pretty good that happened to say that when I was looking for latitude.
Okay, good. Good. All right, what else you got? We don't have much time. We've got about 6 minutes.
Yeah, that's one I've included here. The radius of a magnetic disk is in a 3.5-inch diskette. Wait, sorry. Radius of a magnetic disk in a 3.5-inch diskette is 1.68 inches.
Hold on, I'm confused. The radius of a 3.5-inch diskette, how is it 1.68 inches? How is it not half of the 3.5 inch?
Wait, the radius of a magnetic disk and a 3.5-inch diskette is 1.68 inches. So
okay.
I think it's worded badly, but I think that diskette is 3.5 inches.
Okay, in other words, you've got something that looks like this. There's the diskette, and you've got the thing inside like that.
Yeah,
and they're saying that radius is 1.68, and they're saying it's a 3.5-inch diskette. So that's 3.5 inches. Okay, is my picture right, you think?
Yeah, do you think that the 3.5-inch diskette is a circle or a square?
It's a square. I remember, unfortunately.
Yeah, it's a floppy disk. I never used
floppy disks are square. Just like the disks before them. Yeah, floppy disks were square, and even when they went to hard disks, it was square with a floppy disk inside. In other words, this picture should represent the image that they're trying to paint. What do they want to know?
So find the linear speed of a point on the circumference of the disk it is rotating at a speed of 360 revolutions per minute.
Okay. So we know 360 revolutions per minute, and they want the linear speed of a point on the disk.
On the circumference.
On the circumference, yeah. Well, let's see. We're going to multiply it. That's revolutions. Let's use units because that helps. Rather than calling it RPM, it's revolutions per minute. And as long as they don't care whether my linear speed is in minutes or hours, I don't need to convert it to hours. But I do need 2 pi radians per 1 revolution. And I also need what a radian is. How many radians, how many inches per radian do I have? In other words, that takes care of that.
1.68.
Okay, so it's 1.68 inches per 1 radian. That takes care of that. And now we have a linear speed of inches per minute. Nothing wrong with that. There's our answer. Just multiply all those numbers together and you got your answer. It is in. Did they ask, do they want it in miles per hour, or did they say what units they want it in?
It just says find the linear speed, doesn't say.
Inches per minute is fine. If they don't need it in miles per hour or anything like that, that's good because there's fewer conversion factors to throw in. In other words, right now we've got inches per minute. So multiply 360 times 2 pi times 1.68 and you got your answer in inches per minute. The fact that it's a 3.5 inch floppy doesn't really have anything to do with it, does it? In other words, that could be a 6 inch floppy, which is what they had when I first started in the business. As long as this thing is 1.68 inches in radius, that's the only thing that matters. The 3.5 inch was not even part of our equation. It's in a box, yeah. The 3.5 inch is a hard box. Hard piece of plastic that the thing is spinning inside.
Yeah.
And in terms of linear speed, now hold on a second. Yeah, they said a particle on the circumference, right?
Yeah.
So how fast is that particle going? Well, that's inches per minute or feet per hour or whatever you want. But it's a linear measurement divided by a time measurement.
Yeah.
And notice that when you have a car, the linear speed actually equates to how fast the car is moving.
Yeah.
In other words, let's say I got a car that's got 4 wheels. Okay? And I'll make this quick. And each of the wheels has a linear speed of a particle on the outside. Well, when that thing makes 1 full revolution, then the car has advanced by 1 full circumference.
Yeah.
And in this problem, it's not an automobile that's moving linearly. It's a particle on the edge of this thing that's rotating at 360 revolutions per minute. It's how fast that particle is rotating about in inches per minute. Now, if you know, I somehow could take this thing out of the 3.5-inch floppy and lay it on the floor, it would take off like that. And its linear speed would be the speed that we calculated.
Yeah.
All right, Max.
Yeah.
Hopefully that's helped a little bit.
It did.
Okay. I'll talk to you next time.
All right, bye.
Bye-bye.